Ever wondered why an apple turns brown after you cut it? Or why bread turns to toast under heat? Welcome to the world of everyday chemistry. Chemistry, often perceived as a complex school subject, is a lot more than just equations and lab experiments. It's the unseen force that drives our daily lives, often in the most unexpected ways. From the moment we wake up to the moment we fall asleep, we're constantly in the midst of a grand chemical ballet that shapes our world. Consider something as simple as making breakfast. When you scramble an egg, it changes from a runny clear liquid to a fluffy yellow solid. This isn't magic, it's chemistry. The heat from the stove causes the proteins in the egg to denature, changing their shape and causing them to solidify. Or when you brew a cup of coffee, you're performing a complex extraction process where hot water pulls out the flavor compounds from the coffee beans. And it's not just about food. Think about the soap you use to wash your hands, or the shampoo that cleans your hair. These products work because of a chemical process known as emulsification, where they break down the oils and dirt on your skin and hair, allowing water to wash them away. Even the very act of breathing is a chemical reaction. The oxygen we inhale reacts with the glucose in our bodies to produce carbon dioxide, water, and the energy we need to live. Chemistry is also at the heart of the materials that make up our world. From the plastic in your smartphone to the glass in your windows, these are all products of intricate chemical processes. So you see, chemistry isn't some remote and abstract concept. It's a tangible and significant part of our everyday lives. It's in the food we eat, the air we breathe, and the products we use. It's the silent partner that helps us navigate our daily routines. So, if you've ever been curious about why certain things happen the way they do, stick around as we journey into the fascinating world of everyday chemistry. Did you know that cooking is essentially a series of chemical reactions? That's right, every time you step into your kitchen and begin to prepare a meal, you are conducting a symphony of chemical reactions. Let's take a closer look. When you apply heat to food, you are not merely warming it. You are instigating a cascade of molecular transformations. Proteins denature, fats melt, and carbohydrates caramelize, each contributing its own unique notes to the culinary concert. Consider the humble steak, seared to perfection in a hot pan. The sizzle, the tantalizing aroma, the rich brown crust, all are the result of a complex dance of chemistry. As the heat from the pan permeates the steak, it triggers a series of reactions within the meat. Proteins unwind and reassemble in new configurations, the sugars and amino acids react with each other, and voila! You've just orchestrated the Maillard reaction, named after the French chemist Louis-Camille Maillard, who first described it over a century ago. The Maillard reaction is a form of non-enzymatic browning, a reaction between reducing sugars and amino acids that gives browned foods their distinctive flavor. It's not just in your steak though, it's the secret behind the golden crust of a fresh loaf of bread, the enticing aroma of roasting coffee and the savory umami of soy sauce. In essence, the Maillard reaction is an alchemical process, transforming simple, raw ingredients into a feast for the senses. It's the magic that happens when heat, time, and chemistry align, turning the ordinary into the extraordinary. So the next time you're in the kitchen, take a moment to appreciate the science at work. The crackle of a sauté, the bubbling of a stew, the slow caramelization of onions. These are not just culinary techniques, but a symphony of chemical reactions that tantalize our taste buds and nourish our bodies. Next time you cook, remember you're not just a chef, you're a chemist at work. What makes a lipstick red or a shampoo fragrant? It's all about chemistry. Let's dive into the vibrant world of cosmetics. Each color we see in our makeup palette is a result of unique chemical compounds. For instance, the red in your favorite lipstick might be created by carmine, a dye derived from the cochineal insect. Yes, you heard that right. Nature, chemistry, and beauty all intertwined. But it's not just about colors. Scents too are a blend of chemistry and creativity. Perfumes are a cocktail of fragrant compounds, each with its own distinctive note. These notes are created by volatile chemicals that evaporate at different rates, releasing their scents over time. From the light, fresh top notes to the deeper, lingering base notes, it's a symphony of chemistry playing out right under your nose. Now consider a cream or lotion. Have you ever wondered why oil and water components don't separate? That's where emulsifiers come in. These are molecules with one end that loves water, the hydrophilic end, and another that loves oil, the hydrophobic end. When you mix a lotion or cream, these emulsifiers arrange themselves with their hydrophilic ends in the water and their hydrophobic ends in the oil. This creates a stable, homogeneous mixture that won't separate over time. On a molecular level, it's a fascinating dance. The hydrophilic ends are attracted to water molecules, while the hydrophobic ends are repelled, causing them to align in a way that keeps the oil and water combined. This results in the smooth, creamy texture we love in our moisturizers and lotions. So next time you apply your favorite lipstick, spritz on a perfume, or smooth on a lotion, remember the marvel of chemistry at work. The beauty industry is a testament to the wonders of chemistry, turning raw, often surprising elements into a palette of colors, a symphony of scents, and a texture that's just right. Understanding the chemistry behind cosmetics can give you a new perspective on the products you use daily. From the clothes we wear to the buildings we live in, chemistry plays a crucial role. It's truly fascinating to understand how chemical reactions and elements are intertwined in the creation of materials that we use daily. Let's delve a little deeper to see how this happens. Plastics, for instance, are polymers, large molecules made up of repeating subunits called monomers. These monomers, like ethylene and propylene, are derived from crude oil and natural gas. Through a process known as polymerization, these monomers are chemically bonded together, forming long chains. The properties of the resulting plastic depend on the types of monomers used and how they're arranged. This is why we have such a wide variety of plastics, from the sturdy plastic used in car bumpers to the flexible plastic in your sandwich bag. Now let's talk about metals. We all know that metals are hard, shiny, and good conductors of electricity. But do you know why? It's because of their atomic structure. Metals have closely packed atoms with loosely held electrons that can move freely. This electron C model explains both the conductivity and malleability of metals. It's chemistry that gives metals their character. Textiles too owe their existence to chemistry. Cotton, for example, is made up of cellulose, a complex carbohydrate. The cellulose fibers are spun into yarn and then woven into fabric. Synthetic fibers, on the other hand, are made from petrochemicals through a process called spinning. The properties of the fabric, such as its strength, softness, and resistance to wrinkles, are determined by the chemical structure of the fibers. So you see, chemistry is everywhere, not just in the lab or the classroom. It's in the chair you're sitting on, the smartphone in your hand, the clothes you're wearing. It's in the materials that make up the world around us. Each and every one of these materials has a story to tell, a story of atoms and molecules, of reactions and bonds. So chemistry is not just about experiments in a lab, it's shaping our world in tangible ways. Medicines are miracles of chemistry that save countless lives every day. Every time we swallow a pill, apply a cream, or take an injection, we are experiencing the marvels of medicinal chemistry. But have you ever wondered how these pharmaceuticals work? How do these tiny chemical compounds tackle diseases, sometimes as formidable as cancer or as elusive as a virus? At their core, pharmaceuticals are all about chemistry. They are designed to interact with our bodies at the molecular level, precisely targeting disease-causing entities. Think of it as a lock-and-key system where the pharmaceuticals are the keys created to fit the locks, which are the biological targets. For instance, consider antibiotics. These life-saving drugs are designed to combat bacterial infections. But how do they do it? Well, antibiotics target specific proteins within bacteria, inhibiting their ability to grow and reproduce. They essentially halt the bacteria's life cycle, allowing our immune system to fight off the remaining invaders. Now, let's talk about a more complex example. Cancer drugs. Cancer is a result of our own cells growing out of control. The challenge here is designing a drug that can target these rogue cells without harming our healthy ones. This is where the chemistry gets really intricate. Chemists design these drugs to interact with specific biological targets, usually proteins, that are unique to cancer cells. By doing so, they can selectively kill off cancer cells and minimize damage to healthy tissues. Creating these pharmaceutical miracles is no easy task. It involves a deep understanding of biology, chemistry, and the disease itself. Each drug is the result of countless hours of research, experimentation, and testing. It's a testament to the power and potential of chemistry. And it's not just about combating diseases. Chemistry also plays a crucial role in maintaining our health and well-being, from vitamins and supplements to pain relievers and antacids. From our kitchen to our medicine cabinet, chemistry is a part of our everyday life, influencing and enhancing it in ways we often overlook. So, we've taken a whirlwind tour of the fascinating world of everyday chemistry. We've seen how chemical reactions, elements, and compounds play integral roles in our daily lives, from the sizzle of a steak on a grill and the allure of a vibrant lipstick, to the sturdy materials that shape our environment and the life-saving medicines we rely on. Remember, chemistry isn't just in a lab or a textbook, it's everywhere around us, making life a little more colorful, flavorful, and exciting.